morning, good afternoon, and good evening, wherever you are in the world. I am John Aliotto, a startup evangelist here at Google Cloud. That's right, I am back from week one. Sometimes you get downgraded. You had the amazing Aaron for the last couple of weeks. Now you get me. So sometimes you get downgraded. It happens, but I'll do my best. I'm super excited about today's presentation. We thought deeply about what we wanted to do with this agentic AI startup school. And now we're going to get in really deep. What is it like to really build these things, to manage them, to maintain them? We're going to have a really tremendous presentation from a partner on a special session that's tomorrow. So look out for that. That's going to be Datadog. But today we have the amazing Ivan Niardini. I have seen him many times. He will be talking about building your first agent hands-on with the agent development kit. So he's a tremendous speaker and a tremendous technologist. So I'm very, very excited about today. See, I covered the whole thing on the first slide, but we do need to jump into a little bit of housekeeping. So let's go. We're in week 3. I will call your attention to week 0. There's a tremendous, really informative on-demand session in week 0 that gets you up and going on the fundamentals of Google Cloud, setting up your environment. Very, very important. Please do check that out. If you missed any of the sessions or want to go back to any of the sessions to hear a different section or look at what the speaker is saying, they're all on demand on the website. So you can go to the website for AI Startup School and really dive in deeply to each one of the sessions on demand. So please do check those out. We all know the sessions by now come on Tuesday and Thursday, same time every day. We have the on-demand sessions. And like I said, this week, don't miss it. We have a special presentation tomorrow. So that is outside of the normal band of Startup School. Along with each one of the presentations, we work really hard to make sure there's hands-on training. So we get a Cloud Skills Boost program for each one of the presentations. That way you can really get your hands dirty, go in there, write the code, build the agents. You can do this for free. In order to do that, you need to charge up your Cloud Skills Boost account with credits. And we give you a way to do that. That'll make sure you can log in, you can get the lab going, you can code up your agents and really practice what you've learned over the course of the entire curriculum. If you have any trouble charging up your account or getting your Cloud Skills Boost going, send us an email, googlecloud@google.com. We're there to help. Specifically, startupschool-external@google.com. Okay, that's the help. And then googlecloud@google.com is where the email with all these instructions came from. So check your spam folder. If you don't have that email, then email us at startupschool-external@google.com and we will help. But charge up your account, really get your hands dirty because this is interesting and tough stuff. And we are happy to offer that for you. All right. We love interaction. So please, please, please chat. Please ask questions. You will see down in the right-hand side, you are able to ask questions. You are able to upvote questions. So please interact with everyone in the audience, with our speaker. Ask some great questions. Ivan is an amazing source of information and talent. So ask him a lot of tough questions. We will definitely save at least 10 minutes of the class for Q&A. And here we go. So I am very, very happy and proud to bring to the stage once again a startup school veteran, Ivan Niardini.
Thank you, John. Hello, agents on Google Cloud. So over the next hour, our goal is to take you, from the core concept of building AI agent all the way down to the deploying agents on Google Cloud. So with that being said, let's get started. So we all know that AI agents are incredibly powerful, but as a developers or startups, you also know that they can be really complex to build them. So we are talking about there are some of the common challenges that you need to keep in mind. And these challenges, they usually fall into these 3 main buckets that you see here. So first of all, talking with many of you, one of the challenges that you are facing is this fragmented landscape. So there are tools, models, and framework that are constantly evolving. And so it's a real challenge that you will be able to use them, quickly and keep up with them in a way that they can assist you while you are building your agent. The other challenges that some of you are facing is that as you move beyond from a single agent, things can get complicated. So how do you manage all the dependencies, all the connection between different agents? How you are sure that an agent is capable of delegating tasks effectively between across multiple agents? So even if you're capable of doing that, sometimes you may struggle with debugging what is happening when you start building complex systems like this one. Last but not least, and this is actually a huge one, even if you are able to prototype a very cool agent from on your laptop, building an application that is a reliable, scalable, and easy to govern, it can.
Hi, Yvonne. Sorry to interrupt. We don't see your deck. So if you could please share your presentation.
Oh, yes. Sorry
yeah,
for that.
Not at all. Not at all. See, I kept an Italian joke because it's Italian Takeover Week. They brought me back because we got all the Italian Takeover Week for
do you see the screen
startup school. Let's see. Oh, here we go. Beautiful, beautiful. All right, I will go backstage. Thank you, sir. Appreciate it.
No problem. So to wrap up, actually, John, you just pop up in the right moment. So to wrap up, you have this fragmented landscape. You have multiple tools, models, and framework to build agents that sometimes they are hard to integrate. And even if you are able to put all the pieces together, then you need some best practices, or you need a way to scale your agent from your local laptop where you build them to production. So what if, let's assume that we can ask ourselves, like, what if we want to solve this? Like, we want to solve these challenges that I just shared with you. So in order to do that, you probably need three things. So first of all, you need a standardized toolkit that makes the development efficient and repeatable in some sense. Then you need common protocols that allows you to connect all the moving parts, right? So LLMs with different tools, or agents between different agents. And then the other important thing that you may want to consider in order to solve these challenges is having an agent platform that essentially handle all the heavy lifting of the deployment and the operation around your agents. So these are the three ingredients that essentially will help you to solve those challenges that I mentioned before. And as a Google Cloud, we provide our agentic stack in that sense. So first of all, with respect to the framework, the toolkit to build your agent, we like some months ago we announced Agent Development Kit. This represents a sort of a foundation, and it's an open source code-first tools designed not only to build agents, but also to evaluate and deploy your agent. So in that sense, it covers the entire life cycle of your agentic application. Next, I mean, everyone is using MCP. I will assume that people in this call, you are already aware of what the model context protocol, context protocol is. But essentially, like as a Google, we decide to integrate with it because everyone is using it. And so in few words, this is just an open protocol that will allow you to standardize the way your application get context. So files, data, and with respect to the LLM that you are using. So it's a sort of universal adapter for context with respect to your agents. The third blocks that we decide to build in this case in order to help you solving those challenges that I mentioned is related to Vertex AI Agent Engine. So it represents the platform that I was suggesting before. So it's a managed and serverless platform that allows you to run, manage, and scale your agents in production. So in a way that, and we will see also in the demo, once you define your agent logic, you don't need to think about the infrastructure that the agent needs in order to deploy it. And lastly, and this is something that I'm very excited about, especially because yesterday we donated agent-to-agent protocol to Linux Foundation. So with the agent-to-agent protocol, essentially we provide you this open standard that allows you to enable the collaboration and the communication between different AI agents. So with this last block, you have an entire agentic stack that you can use on Google Cloud and with Vertex AI in order to build and scale your agent to production. With that being said, John already introduced me. For people that doesn't know me, I am Ivan Nardini. I'm an AI developer advocate in Google Cloud. I'm based in Sunnyvale, and essentially my job is supporting the developer community to adopt and adopt our products and services to build great things. So with that being said, this is what we are going to cover in our session. So this is the roadmap. We will start with some recap on the foundation of Agent Development Kit. This is because I know last session was my colleagues, they went deep into what Agent Development Kit is and all the components. So I will just briefly touch some of the concepts that I want to share and that they are going to be useful for this session. Then we are going to cover, we are going to extend the simple agent that we are going to build in this first step with the tools integration and something that I see we didn't cover in this course so far is related to how to evaluate agent with ADK. And then we will move on building a multi-agent system. And finally, we will deploy these agents to Vertex AI Agent Engine. So these are all the four steps that I want to cover. And finally, depending on how much time we are going to have, I just want to give you a brief introduction of the agent-to-agent protocol, and I will share with you a great tutorial that we published recently. So you, after this session, you can go and start play with the A2A as well. For each of these, we are going to have a lot of demo, so the session is pretty packed. So I hope you're ready, so we can start. As I said, first of all, let's do a recap on the fundamentals of Agent Development Kit. So for people that doesn't know yet, Agent Development Kit, again, is an open source framework designed to simplify the agent lifecycle. So we built with this principle in mind. So first of all, it provides you an easy to use interface. So you can get started quickly with the Agent Development Kit. It's modular and flexible. So you can, and I will show you also in the demo, you can integrate external components, like, for example, tools that comes from other framework like LangChain or Crew AI. As you can imagine, is very well integrated with Google and Google Cloud ecosystem. So it provides you, it comes with some multimodal capabilities with text, images, and other data type. The other cool things that it's really something that is kind of disruptive or really appreciated by the community is its local and instant testing capabilities. So we will see that with just one command, ADK web, you speed up a very nice web UI that will allow you to test your agent and improve it. And then, as I said, it has been designed to be deployment ready. So again, with few line of codes, you will be able to deploy your agent to Vertex AI Agent Engine. As I said, I just want to cover some of the core concept of ADK that we are going to explore in the demo. The first concept is the LLM agent. So this is kind of the brain of the agent that you're going to build. It's a worker that uses the LLM. It can be Gemini, it can be Claude, it can be any open model that you have in mind to think and act. Some of the key parameters are the name of the agent, of course, the model that you want to use, and then the instruction and the tools that you want to cover or use with your agents. Talking about tools, tools represent the agent skills. In ADK, a tool can be a Python function, essentially. And you give your agent capabilities by assigning this function, and then ADK automatically handle, the generation of the necessary schema for the LLM in order to leverage the function calling capability. The other two components that are relevant is the runner. This is what essentially execute the agents. And so you can essentially interact with the runner with a command like ADK run or ADK web, depending on if you want to interact with your agent programmatically or through the web UI. And finally, you have these two concepts of session and state that are important, to customize or personalize your agent. So a session essentially represents a single conversation, and the state, I would say, that is a simple Python dictionary that you can use in order to pass data between turns or between different tools that you are going to use without a session. In order to start building with ADK, as you can see here, you really need, you can use a very clean and standard structure. So you have the environment file, which contains all the environment variables that you want to use with your agent. For example, it can be the project, the Google project ID or the model. Then you have the init files that tells essentially Python that your agent is going to be a Python package, and the ADK use it to discover your agent. And then you have the agent.py, which contains all the agent logic. So the prompt, the model, the tools, so all the everything that is around your agent you can have in that file. We will see that when things get complex, and you want to have multiple agents, it's better than you expand this structure. But for people that start today, this is kind of the bare minimum structure that you want to have. As I said, running an agent, in order to run an agent, you have 3 ways, and you can use them depending on each of them. It fits with a different use case. So you have the ADK web, which essentially spin up this fantastic web UI or web interface that has been designed for giving you a tool to visually debug your agent. So you can chat with it, and you can inspect the full trace of the tool calls and the state change. So it saves you a lot of time while you are developing. Then an agent can be executed programmatically. So it's just using the ADK run CLI, you will be able to speed up in the terminal the agent and start interacting with it. And then you have the ADK run, and then you can use also the you can start your agent and interact with it also just starting with the using the Python script that you can create. And I will show you in the demo how these 3 options are different between each other. As I said, depending on your use case, in ADK web you want to use for debugging. The CLI you may want to use while you are prototyping as well, and you want to quick test some functionality. And then the programmatic approach probably you want to use when you want to build a more solid application that needs to go to production. Again, it depends on the use cases. So with that being said, let's jump into the first demo that I have for you today. We will start simple with a simple agent. So I need to stop sharing my screen and then presenting the entire window. Okay. You should be able to see the window. Okay, I hope it's large enough to see on the screen. But this is what we are going to cover today. And the first thing that I want to cover is the single agent. So we start simple, as I said. As I described in the slide, we have the environment file, which contain the environment variables that I'm going to use with my agent. And then we have the init file that essentially will initialize the agent as a Python package. And here you have my simple agent.py that contains a very simple agents that essentially will be it will act as a expert developer to assist me in doing some coding stuff. So as you see, this is a kind of the code that you need to write with ADK in order to create a simple agent, no more than this. So you import the agent library, and then you have this interface that allows you to define name, models, the description of the agent, and the instruction. As I said, from here, you have several ways to run your agent. So we can run our agent using ADK run single agent. And in this case, you will start interacting with your agent programmatically from the terminal. So from here, I can just start playing with my agent. And as I said before, this can be a way that you want to use in order to quickly debug some functionality of the agent. The other, let me see. The other way you can use in order to interact with your agent is again programmatically. So what I did, I've write this script which essentially will allows me to run my agent. And in this script, you have some of the concept that I mentioned in the presentation. So you have the concept of a session and the concept of a runner. And so with those, what you can do is that essentially initiate a session with your agent and passing to the agent several requests, and you will define a logic like this one that essentially will wrap your request in the form that ADK expect in order to generate a response. So in this case, I have two simple questions like how do I implement a binary search algorithm in Python, or can you explain the time complexity of that algorithm? So with that code, all you need to do is executing single agent and then run the agent. And then what is going to happen behind the scene? It will essentially pass this request to the agent, and then it will generate the response again, interacting with the agent itself. So this is kind of the second way that you may want to use in order to interact with your agent. The third one, and the one that I prefer most, is the ADK Web. Because as I said, with ADK Web, you get a very nice UI that will allow you to get a lot of information about your agent. So let me do this. So this is the web UI that I get. In this web UI, I have all of my agents. So let me do this. This one should be okay. And then I have this. So essentially, it does the same thing that we did with the CLI. It creates a session associated to your agent, and there is a run and then manage everything behind the scene. But with that, we can start interacting with my agent, and let's say something simple. Can you write Python function to add two numbers? And the cool thing of this web UI is essentially it traces everything. So for each invocation, you have some information about how long it takes from the agent to execute to run the request, as well as you have all the events tracked. And then for each event, you can explore the events itself, check the request that you submit and the response that the agent generates. As you can see, you have the number of token that has been consumed. So with all this information, I hope you can see the web UI. Why you cannot see the web UI? Oh, sorry, I need to switch again. Yeah, it's not easy to present this screen every time, but yeah. Let's see if okay. So this is the web UI that I was presenting to you. So as I said, per each it traces all the requests, so you can check, how long it takes for the agent to respond, and then you have all events, and for all events you have information about the request and the response that it generates with the amount of token that it consumed. So this gives you an idea of the web UI, and with this web UI, you can quickly debug your agent or improve it depending on the application that you are trying to build. It tracks other things, like including the session itself and it has some evaluation functionality that we will explore later. So with that being said, let's share this tab. Let me go here. Yeah, and share this tab again. So this was the first demo. So let's assume that by using the ADK, you build this very simple agent, and now you know how to execute. So you have 3 ways: CLI, programmatically, and with web UI. Now, this agent doesn't have tool, right? I just rely on the LLM. So what we want to do, we want to expand the capability of the agent in a way that it can interact with the external world. So let's talk about tool integration and evaluation. So to recap, as I said, the tool is just a function that the agent the agent can call to get information or perform some action. And the ADK provides a rich ecosystem of tools. First of all, we have some pre-built tools, like we provide you Google Search or Vertex AI and search integration in order to build your RAG application out of the box. Then we have integration with some popular third-party library like LangGraph or LangChain and CrewAI. And then, as you can imagine, you can also build your custom tools, and you can integrate these custom tools, maybe using MCP or just as a simple Python function. There are other integrations that we provide related to the Google Cloud ecosystem through the application integration, or we have a full, very large toolbox built with MCP in order to integrate your agent with databases. So how the agent execute the tools? I mean, this is pretty intuitive, I would say. So once the agent receive a request, the LLM reason if the request needs a tool to answer, and then it select the right one, generating the arguments to pass to the tool, and then the ADK essentially execute that tool. It can be, again, your Python function, and the result from your function is passed back to the agent. They use the LLM again to interpret the results and generate the final response to the user. So this is essentially the fundamental reasoning loop that is behind, the life cycle of a tool call, which is behind ADK. As I said, creating a tool is pretty simple. In case you want to create your own tool, again, you can use MCP or you can use a custom function. Here you have a very simple get weather function that essentially generate report, the weather in a particular city, and inside this function you can write your logic. One thing that I want to highlight: when you build your own tool, it's not important to just return the results, but please try to return a dictionary that contains, the status of the tool. So if it was able to, in this case, if it was able to use the API, the weather API, and the response associated to the tool. And the other thing that is very important is writing a clear doc string. So ADK can understand which tools the agent can understand which tools to use according to that description. Once you have done this, you can just pass this custom function as a tool inside your LLM agent class, and then from that moment you enable your agent with that tool. One important thing that I want to mention is that, the example that I show you it was a very simple example, but you can expand the tool, and I will recommend you to expand the tool using the tool context, because it will allows you essentially to share all the information that the tools generate in a particular session. So you can, in case you want to call a series of tools, or there is some dependencies between the tools or the agent that you're going to use, you can use this this context in order to maintain that information and use in the upcoming request. With that being said, let's jump back to the demo. So I need to share again my screen. Stop this, present, share, window, and share this. Can you? No, it didn't work. Share the screen again. Window. Okay, this one should be fine. Okay. So right now we just finished to run our single agent. So let's clean this, and now we want to use the single agent with tools. So in this single agent, what we are going to do, we are going to essentially take our agents, the same that we had before, but in this time, we are going to expand the agent in order to use tools. The tool that I'm going to use are the one that you see here. So I have a custom tool, which is the JSON validator. But then what I want to highlight in this demo is that we are going to use different tools from different libraries. So this explains how ADK is quite flexible, because again, if you have some tools that is available in LangChain on CrewAI, you can simply reuse these tools. Plus, as I said, ADK comes with a native integration with the MCP. So in this case, we are going to use an MCP server that I found that allows me to do some read or find some odd topics on Reddit. So again, these are going to be my tool. And once you define this tool, all you need to do is integrating them in your agent, as simple as it is. So with that being said, let's try our agent again. So ADK Web. I'm going to use the ADK Web UI this time. And then I'm going to open this again, new interface. I'm going to switch here. And then stop sharing and share this again. Okay. And then in this case, we're gonna take the agent as a tool. And again, here now we have an agent that is capable of using tools. So we can ask, we can interact with him as we were doing before. But in this case, we can ask him what you can do for me. Can you do for me? And it should be, yeah. So as you see, now is capable of searching on archive, do some web scraping, reading Reddit discussion on a particular topic, and then the JSON validation thing. So in this case, let's assume that I want to search for paper archive. Paper on agent on Google agent development kit. So what it's going to do in this case, it will use the MCP tool that we provide. And as you can see, in this case, it returns 3 papers that they're supposed to be on agent development kit. In fact, the first one, it use agent development kits for industrial automation. And compared to what I showed you before, again, you can check all the interaction. So this is it gives you an idea of the entire event. And here you can see how after I submit the request to the user, he correctly identified that he needs to use the archive search, which is powered by MCP. And this is the request that is submit to the tool, and this is the response that he collect from the tool itself, and then he use for generating the answer that you see here. And this is give you an idea of how ADK interact with the tools, and you can easily follow this interaction using the web UI that I was showing you before. Another thing that we can do from here, and this is actually something that I didn't test before this demo, so let's see if it works. From here, you can also run an evaluation. So all you need to do, I will explain soon all these steps and how it works. But essentially, from the web UI, what you can do is that you can create an evaluation set, and then in this evaluation set, you associate the session, which contain all the interaction that we just had with our agent, and then you select the case and you click on the run evaluation, and here you can decide between two metrics, like which one to use. In this case, we have the tool trajectory, the tool trajectory average score, which gives you an idea how good is the agent to use a particular set of tool, and if the response match the response, like it gives us metrics about the response quality. So we can run this. Let's see if it works. Otherwise, I will show you through the script that I already prepared. It may take some time to run this, but it should work. And in case it doesn't work, it's because there are some issue with the MCP tool, which is something that I already checked in my script. So probably I'm checking the log in the app, and essentially it's taking time to generate the response from the MCP. But yeah, I will show you I can show you the same thing in running the CLI in a few minutes. So this was the tool integration part. So, and as I said, ADK support MCP. So I will probably what is MCP, but again, it's an open protocol that enables the integration of LLMs with particular prompts, tools, or any kind of resource that you want to pass. And the ADK supports MCP in two ways. So the one way is the one that I just showed you. So with the ADK agents that acts as an MCP client. And the other thing is, given some tools that you build with the ADK interface, or giving an agent, you can wrap this agent with the MCP interface and create your server. This is what I show you in the code. So this is just one way that you can use. You can integrate MCP server in ADK agent. So as you can see, it's a very simple code, and it's pretty easy to use. But by now, let's assume that you build your agent, you integrated some tool, and this is something that I was trying to do also from the web UI a few minutes ago. Like how you can improve this agent. Like one of the questions that I always receive from people is that, hey, Ivan, can you tell me what is the right number of tools that I need to that I can add to an agent, and when I can decide that is the moment to switch from a single agent with multiple tools, rather than having multiple agents specialized in some specific task that use a subset of tools. So all these kind of questions, how many tools I can use with an agent, when I need to move to a multi-agent system, you can answer this question just using evaluation. So this is the way that you can use to improve your agent. Now, evaluating agent, it means a lot. So when you evaluate an agent, you don't want to just evaluate the quality of the response. You want to evaluate all the reasoning step and the planning step that it generates while it's trying to achieve a particular task. You want to understand if the agent is capable of getting the right set of tools. And also there are aspects related to memory, safety, and some operational metrics that you need to measure, especially when you want to optimize the agentic application and you want to open it to several users. The good thing of all these, this long list of aspects that you need to keep in mind when you evaluate agents is that for all these aspects, we don't have still a unique response. And in fact, evaluating agent is still an active area of research across the field, especially for reasoning and planning, self-reflection, and memory. It's another aspect that we are still kind of working on how to evaluate. So don't worry about if you will not able to figure it out by yourself how to evaluate those aspects, because we are still working on that. But the other important message that I want to pass is that all these framework, including ADK, they are working hard to cover all these aspects. So sooner or later, we will provide you response or methods and tools in order to evaluate your agent with respect of each of these components. For sure, the message here is that because of all these aspects that you have and then you want to evaluate, that you want to consider when you evaluate your agent, you need a toolkit to do that. So you need a toolkit of quality control and explainable method and metrics that will allow you to measure the agent's performance on your specific use case at scale. And so this is what, again, framework like ADK, they are trying to build, they are trying to integrate in their framework. For now, how evaluation works with ADK, like you have 3 steps essentially. First of all, you need to put together like the test case. So you have 2 ways to put together this test case. You have the test files and the eval set files. And again, like why we have 2 ways, to put together these cases, because it depends on which step of your journey in building agent you are. So you have the test files for the unit testing. You have the integration, the eval set files for the integration testing. And essentially, they are different because in one case you have a single and simple agent session, and so you can use the test file for a rapid evaluation. Or in case you have multiple and potentially more complex multi-turn conversation, that's when you want to run an integration test, so you need a different data structure. So this is the reason why we have these 2 files, one for unit test, one for integration test. Then the second step, you need to decide the level, like the score that you want, the threshold that you want to associate to the 2 metrics that as today we provide, which is the tool trajectory that check if the agent is capable of getting the right tool essentially, or the response match score, which check the quality of the final response of the agent. And then the last step is running the evaluation. And again, also for running evaluation, we provide you 3 methods. One is through the web UI that I was trying to show you before. The other one is through CLI and the programmatic approach. So the CLI, as for the ADK, on the ADK run, the ADK eval allows you to quickly run evaluation against existing test files or the evaluation set directly to the command line. So again, this is something that you want to use when you want to like when you want to run large test suite quickly, or you can also use to automate evaluation depending on how familiar you are with the CLI. Otherwise, if you want to have a more Pythonic approach in some sense on how to evaluate your agent, and because, for example, you are more confident with the Python as a programming language, or you're building a CI/CD pipeline to evaluate the agents, then you can consider to use the programmatic approach. ADK provides you an agent evaluator class that will allow you to wrap your tests in PyTest and running them. So this is about evaluation. So let me go back on the demo, so I can share with you this. Just give me 1 second. Stop sharing this. Share the screen. Windows. Okay. So in this, let me open this. In this, so in the same agent that we built before, as you can see here, I have an eval folder, and in the eval folder, I implemented, like I can use this code to run all the methods that I was saying. So here you have some instruction to how to do that. So you can use the ADK CLI or the PyTest, or the web UI. So in this case, let me try. We can try the CLI. So with the CLI, we can use the we can use the test file that I was showing you in the slide. So this is how a test file looks like. So you have an eval set ID, the name of the test, some description, and then you have the cases. And this is related to a particular session. And once you put together these files, all you need to do is defining also the task configuration, which are the criteria that you want to use the threshold. Now, this is optional. If you don't have this ADK, we run with some default configuration. So let's try to run it. Source, I need to activate bin and okay, and then we can follow the instruction that I put together. So let's assume that we want to use the ADK CLI, so I can get this command. This will run all the unit tests. And this should be, yes. So in the, again, with this command, what you're doing, you're using the native ADK evaluation capabilities in order to run the test. So in this case, it get the evaluation criteria, and then it will try to run the test. As you can see, the test is failing, and this explains why it was also failing from the web UI, because essentially there are some problems with the MCP tool that I'm using. So this explains why the evaluation fails before, but it doesn't matter, because at the end of the day, this is kind of the behavior that you want to validate when you run this kind of test. And again, all you need to do to run this kind of test is preparing the eval set, the evaluation files, depending on how you run it, and then you can use the ADK eval CLI in order to run it. So this is one example. The other example that I want to share with you from the programmatic approach, again, this is this code again kinds of give you the vibe on how you can use, in this case, PyTest and the agent evaluator class that we provide in order to wrap some of the tests that I was sharing with you. Again, the evaluation, the agent evaluator it has an evaluate method that essentially will require you the agent module, in this case, the single agent with tools, which is the module that we are running, and then indicate the data file that you want to use. In this case, we are using the test dev agent.test.json file. And you can, as you can see, this kind of test allows you to have a better control on all the steps that you want to have in your test. In this case, I plan to test my single tool, my custom tool, my archive tool, my web scraping tool, the Reddit one, and then I can also put together some integration tests as a workflow, so where I try different combination of these. So this gives you also an idea of how flexible is running the test in this way. And so you have the programmatic approach, you have the CLI, and then the web UI I showed you before. But because right now the MCP server is failing, it was failing on the web UI. But again, this is what you want to test at the end of the day. Cool. So now you know how you can integrate different tools and how you can integrate, how you can run evaluation with ADK, which is important because it will allows you to improve your agent itself, and most important, understand when it's time to move from a single agent to multiple agents. So let's talk about when do you need to scale, when you need to build a multi-agent system. So first of all, and this is something that we are going to share soon in a podcast that we will run on agents. But the idea is why you need multi-agents, why you need a multi-agent system, sorry. So when do you need to use multiple agents? The idea is that, and it's kind of intuitive, right? But thanks to LangGraph, now we have also some great evidence, I would say. So probably the task that you are trying to address with agent is a complex task. So if you keep using a single agent, you keep adding tools in order to address this task, the single agent can get confused. So LangGraph, they essentially run this benchmark. where they test several tasks with respect to different agent structures. So single, supervisor, and swarm. And essentially what they find out is that the multi-agent architecture, the moment that you start increasing the complexity of the task or the process that you are trying to address or you're trying to cover with your agents, the more it becomes complex, the more the agents start getting confused, the single agent starts getting confused. So you need this kind of structure. You need kind of a multi-agent system in order to maintain higher performance. And it's not just about higher performance, but also have a better trade-off in terms of cost. So again, this is a very nice blog that they publish. I would recommend you to read. But at the end of the day, it's the classic, divide and conquer strategy. Let's say so. In terms of how ADK handle a multi-agent system, the behind the ADK there is this idea of organizing agent in a tree-like structure. And why a tree-like structure? Because it helps to transfer the because it helps to transfer each agent. It helps to transfer the task between each agent in an easy way. I would say in an easier way, a way that you can control better, and in that sense predict all the possible routes that the conversation can take through the tree itself. So in this picture, you can see how you have a root agent, which is a sort of a manager, and then when it receives an initial request, it delegates to the appropriate sub-agent or specialist that will handle the task. But again, behind how ADK is designed, you have this idea of a hierarchical agent tree. So something that I want to share with respect to this process, right? Passing information or deciding when to use a sub-agent. So first of all, the way the manager or the root agent pass the information to a sub-agent is through using the shared session state. So one agent, for example, a research agent, can write its finding to the session state dictionary that I was discussing before. And then the next agent in the sequence, so let's say a writing agent, can read that value from the dictionary and perform his task. So it's very important that you keep in mind this concept of shared session state, so you will be able to, condition the flow of the information between agents, and so in a certain sense, decide which sub-agent to use in your multi-agent system. The other thing that I want to highlight is related to how the root agent or the manager decide which sub-agent to use. And this is and ADK use this principle of LLM-driven delegation. So essentially, the manager has the agent prompts that describe the skills of all its sub-agents, and then the LLM that the manager is using you can leverage the reason capability of the LLM to decide which is the best agent for a particular job and transfer in that sense the control. So again, the LLM-driven delegation principle or idea is the one that allows you to decide, allows the manager or the root agent decide which one to use. Lastly, and this is something that maybe some of you has in mind in terms of questions, let's assume that, so far you describe how to delegate and how to pass the information between agents, but what's the difference between the delegation and using an agent as a tool? So this is something that, again, we are going to discuss in the podcast, but the idea is that essentially you want to use, it depends on how you want to handle the interaction with the user. You will use an agent as a tool when you have some complex task, but that requires, for example, just to send a request and receive a response, rather than, completely hand over the task that you are trying to achieve to the sub-agents. And implementing an agent as a tool in ADK is pretty simple. All you need to do is wrapping your agent with the agent tool class, and then passing this class as a tool in the main agent. that you have. And this is because, I mean, we designed this system with this concept of explicit invocation in mind. At this point, some of you, they may also have another question, like, okay, we have these three approach, but how about loops, parallel execution? You know, how we can build complex multi-agent architectures? So that's why we introduce, you know, the concept of workflow agents. So the workflow agents, essentially, they gives you these. We provide you some pre-built workflow agents that will allow you to handle multiple scenario, for example, parallel, sequence, or loop architectures, or multi-agent system. So in this case, you have a very simple example of a sequential flow. So all you have is that while the sub-agents transfer, like with the workflow agents, you can design your agent system in a way that can orchestrate a sequence of tasks without without the user provide the input for each of them. And so in this case, you will see that, for example, if you want to have a task that it requires, for example, to call multiple APIs, and it's a complex task, so you need to have a sequence of agents. This is how you can put together using a sequential workflow. It's a great structure that you can use. Especially, for example, when you want, I don't know, you want to write an email, right? And you have a sequence of tools where you collect some information and then you run it. Again, it depends. Talking about the use case, when to use, a sequential agent, a loop agents, or a parallel agents. All of them, they respect a sort of execution pattern. So in the sequential agent, you have the linear order. So you execute sub-agent one by one after another in a certain order. The loop agents, it has the interactive cycle. So it executes a list of sub-agent repeatedly until a certain condition is met. And then the parallel agent is the concurrent execution. So you execute all sub-agents simultaneously in independent branches. When do you want to use this? Again, I was trying to explain you before, but the idea is that, for example, a sequential agent can be when the output of one step is the input of the next one. Think about the research draft and format scenario. The loop agent is when you have some task that requires refinement, like a writer, and a critic agent that improves the document over several steps. And then for the parallel agents, like it's best for when you want something that can be divided in several tasks that can run in parallel, of course. So you want to optimize for the workflow agents that you are building. With that being said, let's jump into the demo. So let me do this again. Stop sharing the screen. And then share the screen again. And then share the window. Okay. So at this point, we are in the multi-agent. So with respect to the structure that I was sharing you before, in this case, we change it a little bit. So in this structure now, we have the init file and the agent py, the agent module, but we now have sub-agents. And I'm doing this just because, it allows me to organize the folder in a more readable way, I would say. And so in this case, we have two agents, right? The code agent and the search agent. So let's see the search agent. Again, the search agent is an agent itself, so it has the same structure of the previous agent with tools and the agent logic. But in this case, as you can see, we have what we did is that we select the tools that will allow me to run the archive research and the Reddit research. Why so you can imagine why I'm doing this, because the search agent, it can be an agent that can be parallelized, right? Because I can run in parallel a research that goes on archive and a research that goes on Reddit. So that's why I'm kind of building, wrapping those tools in one agent. And in fact, we are defining this new agent as a parallel agent, where I have the two sub-agents, and I've wrapped them using the parallel agent. And as you can see, again, same structure as before. The only thing is now what I'm doing is I'm assigning the archive tool to the archive researcher, the MCP tool to the Reddit researcher. And notice how I'm using the output key. So in a way that, I can control better the flow. So the input and the output that this agent generates, because they need to communicate. And then I use the parallel agent to combine them in a structure. So this is just an example. So let's run. Before I run it, once you have this, all you need to do is, taking this agent, importing in your main structure, and run it as a sub-agent in your root agent, which was the agent that I had on top of the chain in the representation that I showed you. So let's run again ADK web in this case, and I just want to show you how it runs this search in parallel. Oh, what happened here? ADK web. Let's see what is happening. Oh, I forgot to close one of these, probably. Let me do this. Let's see, it is running. Let's see if now it works. This should be close, hopefully. Okay, so I had the port busy with the other web UI. Let me share again my screen. Share the screen. Done. Okay, so this is the web UI that I had before. And in this case, we want to select the multi-agent that I built. So again, we can interact with it. Hello. How are you? Can you what you can do for me? Again, as before, and then run search for ADK paper, search for ADK on archive and Reddit. So let's see, in this case, you see is transferring to the parallel agent, and the parallel agent, it should run in parallel. He's asking if I want sub-agent. In this case, it looped me back, asking for if I want a subreddit, would like to search for a discussion about ADK. I can say yes, ADK, Google ADK discussion. But the fact that he was able to, integrate, run the Reddit sub-agent and asking me, it shows you how he was running in parallel the two requests. I don't know why he's failing. Yeah, because he confused with Google. So as you can see, my multi-agent system is not that smart. But the idea is that, so this should give you an idea of how the parallel agent works. And again, if you go on the invocation, you can check what is happening behind the scene, how it runs this in parallel. So here you see that are running in parallel, as well as if you go on the event and we find this, you can see how those two agents that I define are part of parallel agents that can get have different tools access with the archive search as well, and the Reddit outpost. So this is give you an idea of how we expand our agent to make it multi-agent and parallel. I should optimize a little bit the prompt that I pass to this agent so it's able to handle this kind of request better, but again, it gives you an idea. Okay, so with that being said, let's go back on this. And we have two sections to cover before I finish. So this one, I will try to be fast on these two. So first of all, like, let's assume that your agent works perfectly, and now you want to deploy your agent. So deploying an agent in production, it can be tricky, especially if it is a multi-agent. So that's why we decided to introduce Vertex AI Agent Engine. But Vertex AI Agent Engine is not the only option that you have on with ADK. ADK integrates also Cloud Run and other options like GKE, and of course you can deploy on your custom infrastructure. Why I like Agent Engine? Because it's a fully managed services that has been designed to host agentic applications. So has some features like, for example, the session management that they comes for free. Rather than it's integrated with the evaluation system that the evaluation services that we provide. So it has some nice features that will allow you to cover the entire life cycle in terms of deployment for an agent, compared to other services where you need to build yourself. But in general, why you need an agent engine? Because if you don't have an agent engine like this one, you need to if you want to deploy your agentic application, you need to figure it out the servers. So you need to be familiar with some framework like FastAPI, Django, or whatever. You need to build your Docker files, and you need to configure a GCP project by yourself in some sense in order to enable all the services to deploy the agents. And then you need to handle your infrastructure operation, like connecting your observability tools and managing them in a way that it will allow you to debug your agent if something happens. With the agent engine, essentially, all the deployment part, the code part, is handled with just one class. So you just create your agent and you deploy it, and then Vertex AI, because agent engine is part of Vertex AI, Vertex AI handle all the aspects related to the deployment itself. So auto scaling, container vulnerability checks, all these kind of things. And then, as I said, Agent Engine is integrated with some nice services like Vertex AI evaluation services, as well as it has some built-in session management capabilities. We are going to have we have in private preview a manage memory services that we will integrate. So again, the platform is designed to host agentic application natively. So what is a Vertex AI Agent Engine? This is how it looks like. It gives you, these are picture, it gives you an idea of how like complete in some sense is the platform. So you can define the agent. I know we are talking about ADK, but you can define the agent in whatever framework you like. You just need to register the agent in Agent Engine, and then it will provide a full runtime, manage runtime, some pre-built observability tool, evaluation, connection with external tools are supported as well, like MCP or the tools that we were discussing, including A2A. So, and one of the aspects that I want to highlight, which might be relevant for startup, is that from Agent Engine is integrated with Agent Space. So if you develop an agent and you want to make it available to business user without you building a nice UI for business user in order to interact with your agent, Agent Space is the place to go. So the fact that we have this direct bridge, it will speed up a lot, taking your agent from your local laptop, deploy that scale, and then make it accessible to a business user or any kind of user that actually you want to serve. In order to deploy an agent, again, 3 steps, very few steps. You develop your agent, you just use the create method to deploy it, and then you query your agent. You have different methods to query your agent, and also the Vertex AI Agent Engine SDK provides you some methods to manage your agents. So get the agents that are deployed, or deleting them, undeploy them, all this kind of operation around the agents. This is how deploying an agent on an ADK agent looks like. So again, it's very few lines of code. You import the Agent Engine library from the Vertex AI package. This is Python code, by the way, Python SDK. And then you create an agent, let's say endpoint on Agent Engine using your root agent that we were just discussing. Of course, in this demo, I simplify things a lot. We are going to deploy just a root agents that use a subset of, like a root agent that has multi-agents, but just a subset of them, and we are going to deploy them as a unique endpoint on Vertex AI Agent Engine. Probably in the reality, depending on how complex is your task or how complex is the agent that you want, the task that you're trying to achieve, and the agent that you're using to address that task, you may want to deploy those multiple agents on different endpoints and then connect them through a framework like the agent-to-agent protocol. So this also should answer a little bit the questions why you want to use an agent-to-agent protocol with respect to the native multi-agents architecture that we provide in ADK. I think this use case where you have multiple endpoints on Agent Engine, it can be a relevant one when you want to use A2A, apart from all the capabilities that we will discuss. So with that being said, let me go back on the demo. So this is the kind of, okay, and then the window, share this, and then I do this. Okay, you should see, share my screen again. Okay, you should see the screen now. And that's perfect. So as a part of, so the last demo that we run in this repository is the sub-agent, the multi-agent deploy. So I have my multi-agent here. As I said, all you need to do in order to deploy is taking your root agent that you defined before, and using the create module in the Agent Engine package that is here in order to deploy your agent. Again, you pass all requirements. In this case, we use multiple tools. So you want to pass the dependencies with the LangGraph, archive. Again, in this case, especially when you have, for example, if you use tool with MCP, probably you want to deploy the MCP tool in a managed services like Cloud Run, and then connect this agent to the remote services. You don't want to deploy this everything on Agent Engine. So these are all best practices that you can implement. And then, I mean, because this root agent use all these agents that we defined before, we also want to include the entire package. So it will be able to use them once you deploy. So let's close this, clear this. And then all I want to do is going in the multi-agent deploy. And then I have my deploy module. So I run deploy, run deploy. And so what we'll do behind the scene, as you can see in a few seconds, it will start packaging my agent. So we will check the requirements. If some of them are missing, they will append them. It will pick all everything, upload on a GCS bucket that I define, and then kickstart a long-run operation that will deploy my agents to production. So I already done this. So what we can do is that once the agent get deployed, you can write a script like this one, which is pretty similar to the script that we write before, except that now, rather than interacting with our agent locally, what we are doing, we are getting the agent that we deployed. We create a session with the remote agent, and we have some test message that I define, and I pass them using the stream query, and I will get the response. So let's try this. Let's see if this works as well. So I am in the right repo. So I do v run and then query my agent. And so what is going to happen is that, it will initialize a session. It will connect with the deployed agent. It will initialize a session, and then it will start interacting with those query that I set before. Yes, how are you? Are you there? I'm here. How can I help? And now what is happening on the remote agent, is using the tool, the archive tool that we define in order to collect some paper about, in this case, it was machine learning. The cool thing of all this is you can track, you can see what is happening, because once you deploy the agent on Agent Engine, let me share the screen again. This is what you will get. So let me do this, and let me do this. So you will get an entry in what is represented by, let me do this. The Vertex AI Agent Engine UI. So this is how the UI looks like. So as you can see, to be sure that everything was working for this event, I test so many agents. But essentially in this UI, you will get all the list of agents that you deployed. You can add more information about them if you need it. So this is one of the agents that we deployed recently. And if you click on these agents, I can give you an idea. Share this up. These are a view of the metrics that the agent engine collects for you. So you have the query per second, you have the query latency. If you get some ratio, you will have also the error ratio. You have the query latency. So all this information are useful for detecting some anomalies in the performance or the reliability of your agent. Plus, you have some metrics about how much the resource consumption of the agents in terms of CPU, in terms of memory. So you can also control a cost with this. So this gives you an idea. The other thing that now that I'm thinking, I forgot to integrate. So we deploy our agents without enabling tracing. But if you deploy your agent with the enable trace flag that you can find in the agent class, you will also be able to see the tracing, exactly similar tracing that I showed you in the ADK Web UI. So this gives you an idea how, this is the power, like the cool things of Agent Engine. Like once you deploy the agent, it manages all these aspects for you, including session. And so a session is especially important because it will allows you to track like the number of the user that interact with your agent as well. And through the session, what you can do, you can collect those information to create an evaluation data set and run your evaluation. So in that sense, like you close the loop and you keep improving your agent that you deploy to production. If you want to see an example of how to do that, check out the starter pack. That it gives you an idea of how to stitch together all these pieces using a CI/CD integration. Okay, so with that being said, I also covered this part. In the last few minutes, I just want to do a quick introduction on 8-way protocol. I know it was a long session, but I really want to cover all these topics, so in a way that you can go and check by yourself. I don't think we have time to run the demo of this, but I will share with you the notebook. So we are all agree that today agents needs to talk, right? And what I was trying to show you in this demo is that probably depending on how complex is the task that you are trying, or the process that you are trying to make it agentic, like you want to use high-level framework like ADK or CrewAI because they are easy to use, they are you can quickly iterate and develop with them. But if the task or the subtask that you are trying to address with your subagent is more complex, you want to have some low-level framework like LangGraph that allows you to make that sub-process agentic. So the message here is that, especially according also to my experience, like people, they are building agents that are heterogeneous in terms of framework, depending on the task that they're trying to achieve. And when you have this situation, like because CrewAI, LangGraph, and the ADK, they are not framework that has been designed to interact natively together, that's when you want to use, that's when you need a protocol, right? And that's the reason why we introduced the agent-to-agent protocol, which, by the way, like we launched it I think 2 months ago, but I'm so happy that yesterday we donated it to the Linux Foundation, because we really believe that, as a developer, you can contribute and, make this protocol as a standard for your applications. And so the agent-to-agent protocol, again, is pretty simple. It's an open standard designed to create this common language. That's the right word, like common language between all these agents. So it facilitates the communication between a client agent and a remote agent, where the client agent is responsible, for formulating and communicating the request, while the remote agent is responsible for acting on those requests and try, to solve, address the request with the multiple agents and take the right actions, actually. The capability, like here you have a list of the capabilities of the agent-to-agent protocol, but as you can imagine, they're quite intuitive. First of all, we want to improve the discovery capabilities because you have this complex system with multiple agents, and we do this with the model card, which essentially is a business card of the agent. I will explain you. And then, of course, there is this negotiation part. So we define a protocol in a way that you can handle different modalities like test, form, audio, like other components that will have in your multi-agent system. And the negotiation part, I think, is pretty important, not just with respect to the interaction between agents, but recently I was talking with these developers that essentially, thanks to the agent-to-agent protocol, you can standardize, right, the interface that where different agents they communicate, but also the way that the agents that are part of the protocol generate some outputs. And this is so important when you want to build some interface on top of it, because in a way that if you standardize the way the agent negotiate or communicate between them and produce some output, then it's also easy to map some UI component on top of it, and then creating very powerful application. So negotiation and collaboration is important, but also there are out of the box of this system, they comes with some task and statement management that will allow us to handle, long-term operation between agents, checking the task status, and all other components that you may want to have with this complex system. So in order to explain how A2A works, let's start with a very simple example. So let's assume that you have a two-agent system. One is a client, and the other one is the server remote agent. And this scenario is so simple, but it allows us to introduce all the key components, which is one I want to explain to you today. So the first step that you want to cover, or the answer that you want to ask, is that I have two agents, right? Agent A, agent B. How agent A knows about agent B, and especially how he can, figure it out what agent B can do for that. So this is the first kind of question that you want to answer when you have multiple agents, and that's how the agent-to-agent protocol. That's the reason why the agent-to-agent protocol introduced the agent card. So the agent B published an agent card. Again, think of it as a business card. It's just a standard JSON file, where it contains the well-known URL of the agents. And this card essentially tells agent A everything he needs to know on agent B in order to start a conversation. So the agent B name, what it does, the HTTP endpoints URL for the agent-to-agent communication, the skills that the agent B provides, and also some special capability, like if the agent is capable of handling streaming conversation and how to authenticate with it. This is how the agent card looks like. So again, I already told you the kind of information that it contains, but it's a pretty simple to define an agent card with respect to your agent. In this case, is our currency agent that we define. Okay, now with the agent card, agent A knows agent B, knows there is an agent B and knows what agent B can do, but how agent A and agent B now they start to communicate to each other. So how they can talk to each other. And that's when to ask these questions, agent-to-agent protocol adopts some of the standard communications protocols in some sense. So in this case, agent-to-agent uses the standard HTTPS for a secure communication. And so with this standard, what you have is that the envelope of the message that the agent A sent to agent B is in a format is a JSON RPC 2.0, which is kind of a simple way to call function on the remote server. And then inside this envelope, you have the message, and the message has several components. So the message itself represents like one turn in a conversation. So in this case, it can be agent A asking a question to agent B, and then it has a role. It can be user or agent, and it contains part. And each part is actually the content, right? So it can be text, it can be file, it can be different data structure. And so when the agent B gets the request, if the request is simple and it can be completely quickly, it might respond directly with another message, as you can see here, which contain the answer. And all this process of stitching together this communication layer between agent A and agent B is implemented with these components, which is like some line of codes represented by the agent executor. So the agent executor is a Python class that you can write, and it links the two agents in a way that they can operate. Okay, they can use this protocol that I just described, this process that I just described, to interact between each other. So the scenario that I just described is the simplest one. So it's the one where the task is so simple that the agent B sends the request, agent B return the response. But what happens when the request it gets complicated? So agent B needs some processing time. In this case, you cannot expect that the agent will just wait for the response. So that's why we introduce the concept of, in a way, we have this concept of task. So task is essentially the job that the agent B needs to do. And so when the job is complex, you can define a task, and the task has an ID and a status. The status can be, submitted, working, or maybe failed. And essentially what happened in this kind of a situation is that the agent B send an initial request. Agent B might respond quickly, or, in this case, it will generate a task. And he say, hey, I created a task to this particular request. It has an ID and is working. And then the agent B knows this task and keep polling the agent B till he gets the final status with the response. And how the response is passed? The response is passed again with an artifact, which is essentially kind of the same idea of the message, but in this case, with respect to these are asynchronous, let's say, communication. And in the artifact, you have parts, again, with text, file, or JSON structure. As you can imagine, this kind of interaction, it's a good way to solve the scenarios where you have complex tasks, but polling, so the agent A that keep polling the agent B is not efficient. So that's why, you want to improve, you want to make this system a little bit better. Or, by the way, polling is not efficient in all scenarios. You may have scenarios where you cannot just expect that the agent A keep polling agent B. So that's why we introduce this support for the streaming using the server-sent events. And in this sense, all you need to do is enabling in the agent card of the agent B the streaming flag. And then the agent, what is happening is that the agent A maintains an open connection with the agent B, but it's not polling it anymore. So the agent B can push updates to the agent A as they happen. And so this update, again, they can be the initial task. It can be the message that say, hey, I'm working on this. I'm working on a particular task. It will be complete in a moment. And it can be at the end the final artifact when you have a large summary, for example, and the agent B send it back in writing each components of it. So this gives you an idea of how we handle also complex situation. In order to enable these capabilities of streaming and processing and notification, you just need to pass some agent capabilities using the agent capability task with the streaming and push notification flags enabled. And then again, just adding the capabilities flag in the agent card, and then you're good to go. Do you remember I mentioned the execution component? So once you have the streaming part enabled and the push notification, the execution components, it looks like that. So it's this Python function that stitch together the communication that you're using. So you have an init method that initializes the agent class. And then you have the execute method, which essentially what it does is the main entry point of the processing. The entry point of the processing. And here you have, this is a very simple example, it's pseudocode. You have everything in the samples that I will share. But what it does is extract the user query from the upcoming request, and then initiate a task, and associated to this task you have a request, and then he monitor the status of the task using the task updater, and it update the task according to what is happening in the processing, and then it send back updates to the client. So this is give you an idea and how it works, like the execution part. This is the second part that I was saying with respect to the updates. So it stream the task if it's complete, if it is final, and if it contains an artifact through the updater that we just defined before. And of course, you can have also a method that will allow you to cancel a task that is ongoing. Once you have put together the agent card, the agent executor, all you need to do is starting the 8-way server, and the 8-way Python SDK provides a Starlet application class that essentially uses Starlet and runs ASGI server, like a unicorn, to run an agent-to-agent compliance server. Okay, so this is how it works. I think we don't have time to cover the demo. I just want to check with John about that.
I don't think we have time for the demo. I know we're probably over time. I do want to get Yvonne to some of these amazing questions, but thank you, sir, very, very much. That was amazing. A lot of great stuff. I want to brag here on Yvonne for a second because he is absolutely criminally underfollowed. So how do we follow you, Yvonne? You write great blog posts, you have a podcast, you put tons of technical stuff on X and everywhere else.
Yeah.
So please tell us how we can find you.
Yeah. Thank you, John. So, I mean, for everything I shared, I can share with you. So just feel free to reach out. I'm active on LinkedIn and Twitter. And I'm always happy to answer questions. So I don't know if we have time to answer some of them. I hope so. But yeah, in case you have question that we are not going to answer today, feel free to reach out. I'm happy to answer.
Okay, nobody is telling me in the chat I can't go forward, so I'm just going to go forward because that's
okay.
All right. So we have built agents, but we still have to train models, right? If one wants to fine tune a model, this will be separate from the whole ADK, right? And ADK is mostly purposed to the environment and run, but the model is a separate thing. So how do we use our own models? How do we train our own models? What's the deal here?
Oh, that's I love this question. So thanks to the developer that asked it. So yeah, depending on the stage of your development, if you are still developing the model locally, there are so many frameworks today that will allow you to optimize, small LLMs. So you can implement fine tuning. Some of them are, Axlot. It's a one framework. There are many that will allow you to run it locally, but let's assume that, for example, you want to scale because you want to run multiple experiments in parallel, or you have a large amount of data that you want to use to fine tune. Again, we are in the same scenario where you need a platform, and on Vertex AI, we have several services that will allow you to fine tune your model. If I have to suggest my favorite one, Ray on Vertex is my favorite one. It's easy to use. Use a completely open framework to tune the model. It gives you full control of the training job, so it's easy to debug. That's my suggestion. So I hope I answered the question.
And specifically, the ADK supports Light LLM to integrate with different models. So they can use different types of models. They don't have to use Gemini. They can use their own model through Light LLM.
Oh, correct. So that's a very good point. Once you fine tune the model on Vertex AI, you can use the integration with Light LLM to integrate the model deployed on an endpoint. And good point, John, on the fact that ADK is open. So all the demo I run with the Gemini, but it support Claude, it support whatever model you like.
Absolutely. Amazing. Okay. Question 2, when do you use a function tool versus an MCP tool? Great question.
Oh, yeah, that's so this is something that actually came out in the hackathon this weekend. So my decision tree in that sense is that if I want to use an API, right? Because I want to enable my agent with some capability. So if the API it already has MCP, server, or something that has been, of course, built in a way that is safe. I mean, now those MCP server, they have also a score in terms of safety and everything. So I will go with that. I will not build, a custom API integration. Otherwise, if there is not an API integration on MCP side, then I will consider, to build my own custom function using the function tool.
So this is the classic buy versus build trade-off when I'm building software.
And it depends also how much time you have, right? For example, if you're running an hackathon, you want to reuse as much as possible, right? So you use 100%. MCP.
100%. When do you use A2A protocol versus sub-agents? Similar answer, I would guess.
Yeah, I would say that, as I said in the demo, right, the agent-to-agent protocol, it gives you more flexibility. Like, especially if you deploy, what I showed you today is just a playground, right? But what is going to happen in the real life is that, you have an MCP server that is deployed on a managed service like Cloud Run. And then you have multiple agents. Depending on how complex is the task, you want to optimize for the resource that associate to these agents. So you need to deploy these agents on, multiple Cloud Run or different endpoints. Then right now, ADK is still working on the integration on when you have agent on multiple endpoints. So that's when you want to consider, agent-to-agent protocol, because the idea is it's more close to those communication standards that you have with respect to, client-server application, like the one that you're trying to build today. And especially when you have multiple server agents, let's say, so it's pretty compelling, right? Having a flexible protocol like this one.
Absolutely. So, it's the same as we always do in software. We always build the same things over and over and over again. None of this is really conceptually new, except for one thing. So when you're building out software, you componentize things. You build little components. Components do work. We have single responsibility principle, and then we map those components up to some sort of manager or orchestrator, right? It's the same way with sub-agents. If you're building your own capability, your own task, it's highly unlikely there's another agent out there that does the particular work you want to do. You would have to write your own. A2A envisions this world, and we're not there yet, where there's hundreds or thousands or even millions of agents out there running successfully, where you can go out and grab one and use it for a particular task, right? We used to have to write our own SMTP work to send emails. We don't do that anymore, right? So you get APIs, you get agents out there, and the world changes.
And about that, actually, I would say the most, the easy answer to also this question is that, with respect to what you just mentioned, right? You have sub-agents, and usually what we show you today, you build just with ADK, right? But as you said, right now, everyone is building agents with respect to, some APIs capabilities that they provide. So you have this world where you need to connect multiple agents that are not built with the same framework. So how would you do that? That's why you need a protocol. So yeah, no, that's 100%. A good point.
It's again, it's service-oriented architecture, right? You have all these services, you have some interaction. In service-oriented architecture, you generally have loose coupling. The new conceptual leap for agents communicating with one another is collaborative coupling. We don't have collaborative coupling right now. These agents will work together. They will talk back and forth. They will collaborate to get a result, right? So that's the new conceptual leap. Everything else is exactly the same as we do it, just different protocols, different things you got to type in the IDE. Okay. How can we create a reasoning agent? For example, if we need to create a master agent, which can reason out the conversation and decide when to invoke an agent or tool based on the context. Reasoning, how's that fit in?
Yeah, no, I mean, we trying to briefly touch this one. I mean, if you're looking for an example of how to build an agent that is capable of using an agent as a tool, we can share with you the example. But the integration with what I show you is pretty simple, right? We provide in ADK, we provide an agent tool class. You wrap your agent, and then you pass this agent as a tool. So in the master agent, as you call. So yeah, this is the simple, implementation and the simple answer, but I can share an example to do that.
Amazing. Okay. And then all the Gemini 2.5 models are reasoning models. So
yeah, correct.
Yeah. Agent powered by a reasoning model, it will reason out the problem, given the opportunity to do so.
Yeah, correct.
Okay, amazing. And then we'll go one last one. And the reason why I want to ask this is because it dovetails beautifully into tomorrow's session. If you're still with us, thank you. When an agent has been rolled out, how do we judge its efficacy, accuracy? Is there instrumentation infrastructure available for this? So wonderful, wonderful question.
Oh, I love this. So in terms of its efficiency, as I show you, you have some standard metrics. Vertex AI Agent Engine, it shows you the query per minute, like it gives you all these information about, how fast is the agent, or the kind of throughput that it can handle as well. So these are in terms of efficiency. In terms of accuracy, so we shift on evaluation. As I said during the presentation, it's still hard to evaluate like an agent in all the aspects. Right now, we are good in evaluating the response. We are good in evaluating which kind of tool, if it picks the right tool with respect to the user input in several combinations. But there are aspects like memory, there are aspects like self-reflection that we are still working on it. As a Google Cloud, we are partnering with several companies as well. So, for example, if you want to evaluate a multi-agent systems, we put together an example together with Arise AI. If you have a problem, you want to evaluate an agent but you don't have data, we put an example together with weights and biases to how to synthesize data to evaluate an agent when you are not sure about how the agent is good before to deploy. So yeah, there are all these aspects, John, and we are still working on that, but happy to collect feedback in that sense. What kind of evaluation are people trying to implement, so we can build accordingly.
Wonderful. That's all a lot of that's in Vertex. Like you said, a lot of that's with partners. We're going to have Datadog tomorrow. They are going to go deep into observability, logging, management, monitoring of these agents as they live in the real world. So that is going to be it for the questions. Thank you, Yvonne. I'm going to let you get a drink and take it easy now. Thank you so much for the time. This is amazing. Wonderful.
Thank you, everyone.
Follow Yvonne on X. Find him. Amazing stuff. And we will get to the slides and then get out of here. Thank you for being patient with us. Please sign up for the Google Cloud for Startups program. This is where you begin your relationship with Google Cloud. This is where we give you things like credits, but more importantly, this is where you can create a relationship with us. Our entire group, our entire team is here to help create success with you in partnership with Google Cloud. And this is the front door to that. So please sign up. You can get an account representative. You can get access to customer engineers. You can get access to people like Yvonne, architects like myself. So this is where you begin your relationship with Google Cloud, and we will change the world together. So please sign up here. The next slide is an amazing, if I can change the slides. Oh, I'm so incapable. Okay, here we go. The agent handbook, go check this out. We did a deep dive today, but this is a lot more details, a really great place to go. You can read through this and get a lot of the information that's presented to you, but a really wonderful, wonderful resource here, the agent handbook. Of course, we talked about our Discord community. Please go there. Lots of Googlers are there. Lots of people are in the community. Ask your questions, help answer questions. If it's a really great place to go and talk about agents and every other thing associated with AI. So please do go there. And then tomorrow we will have observing LLM applications with Datadog. So this is going to be an awesome presentation. It's out of band of our normal cadence. So Wednesday, June 25th, tomorrow. The times are there, so you can map it to wherever you are in the world. Please do attend. This is going to be an amazing session and answer a lot of questions about how to live with agents in the real world. And I think that is it for us. Thank you, everyone. We went over time, but we really appreciate all the interaction today and your valuable time spent with us. Thank you so much. Talk to you next time.